Hello, students, and welcome to another sixth grade math episode with me, your host, Mr. Nerlich. Last time we worked with dividing with mixed numbers. Today we're going to use all of our knowledge and we're going on multiplying, dividing, adding, subtracting with fractions, mixed numbers, and some whole numbers, and we're going to solve rational number problems. Sometimes when we solve rational number problems, there may be more than one operation needed to solve. We may need to use more than one operation. All right, and there are some steps that I will share with you that's going to help you solve these problems. So there's five very important steps. All right, so step one, we want to identify the important information. This can be through you highlight the important information, you box it in, you circle it, underline it, however you want to do it. But you find a way that helps you understand and organize the problem, and you keep using that same way throughout the year so that it becomes second nature as you're doing it. Next, we need to find what the problem wants you to solve for. Such as the last lesson, we had to find how many sushi rolls could Bob make. So that's what we knew we had to solve for. Okay. Then you need to locate the keywords in the problem. And that's going to help you determine the operation or what operation or operations you will need to solve. And if you've never seen the S at the end in parentheses before, that just means that this word can be operation or operation. Sometimes you're going to see a problem that has one operation and you're good, but a lot of times we're going to see problems that have multiple operations that will need to be used, and that's okay. It's just going to take us a few more steps. Then step 4, you're going to just solve the problem. Okay, we're going to solve the problem. And then step 5, which is equally as important as solving it, if not more important, is check your answer and then ask yourself, does my answer make sense? Okay, if Johnny solved the problem and the answer ended up being 17 million, and the question was, how many pencils did Sally use during the school year? And Johnny said 17 million. Well, it might feel like 17 million because maybe Johnny used a lot of pencils during the school year. However, 17 million pencils is totally way too many. So then we'd have to look back and say, okay, does my answer make sense? No, 17 million does not make sense. Maybe Johnny or maybe Susie used 17 or 170, but clearly she did not use 17 million. So then we'd go back and look at the problem. Maybe there was an error somewhere in the problem. All right, let's work through an example. Now, in this example, I'm not going to write the actual word problem because you have it on your notes, but I will read it to you so we can kind of break it down and understand what's going on. So it says, an art student uses a roll of wallpaper to decorate 2 gift boxes. The student will use 1 1/3 yards of paper for one box and 5/6 yards of paper for the other box. The paper must be cut into pieces that are 1/6 yard long. How many pieces will the student cut to use for the gift boxes? Okay, so something before I even get into the problem and stuff, something that I notice is that I have 2 different size boxes. That's why the amount of paper used for those boxes is different. And then I know that I have to use strips that are 1/6 yard long. And you notice the question, which in 6th grade, 99.999% of the questions being asked will be at the end of a word problem. So how many pieces will the student cut to use for the gift boxes? So we have to answer that and label it with pieces of paper so that we know that that's our actual answer. So for step 1, we have 1 1/3 yards of paper for one box, and then we noticed we had extra information. We have 5, 6. This is step 1. So we had 5, 6 yards for the other box. So step 2. Step 2, we have, well, what does it want us to do? It wants us to cut into pieces of paper. So pieces of paper must be cut into 1/6 yard long pieces. Okay. Then we see step 3 is keywords. So a keyword that I noticed in this problem is cut. Okay. And cut means divide. So if I cut a pizza in half, I would have two big pieces of pizza, but they would be smaller than the original whole pizza, right? And if I push those two pieces back together, I would have a whole pizza. All right. Now, there may be other keywords in these problems. However, sometimes when you're solving these problems, you're not going to worry about if you found every keyword. You're just going to start to learn that, okay, I think this makes sense because I've used this same operation on previous problems that were like this, and you start to learn that I don't necessarily need a keyword or will be given all my keywords. So there is an operation in this problem that we're going to find out we have to do that there is no keyword for, and therefore we kind of have to figure that out on our own. What do we need to do? Before we get there, step 4. Okay, step 4 says solve the problem. So I have 1 1/3, right? And I need to get mad. So I get mad. And I multiply 3 times 1, which equals 3. And then 3 plus 1 equals 4. And I keep my denominator, and so I have 4/3. Okay. However, the other fraction in the problem is, what is the other fraction in the problem? Well, the other fraction in the problem is 5/6. So if we want to find a common denominator, we recall that we have to use the GCF, and the GCF between those two, 6. So, is we want to get to 6. So the GCF, we want to multiply by 2. So if I multiply by 2, I'm going to have 4/3 times 2/2, which equals 8/6. So now, I'm going to move up here, I can do 8/6, and I have 5/6. Now, so far, we found that the operation we need to use is divide, but do we really want to divide the 2 boxes we need to cover, or do we want to save that for later? We want to save that for later. So right now, we want to find how much do we need total paper. And when I know total or in all, that keyword that you know would tell us to use the operation of addition. So now I have 13/6. Okay, so that's my total amount of paper that I will use in order to cover both boxes. But in order to cover the boxes without wasting any extra paper, we need to cut them into strips or pieces that are 1/6 yard long. So now is when our division comes into play. So we have 13 over 6, and we're going to divide by 1/6. And that's going to equal 13 over 6 times 6 over 1. And when I cross simplify, I'm left with 13 over 1, which equals 13. Okay. We're done, right? No, we're not done. We're not done because we didn't label it. So we need 13 pieces I needed 13 pieces of paper. Okay. And then we need to check, does my answer make sense? Well, let's see. Let's make some room here. So I can see I have 13, okay, over 1. And if I multiply that back times by 1/6, because that's what I originally divided by, I'm going to get 13 over 6. So I get what I started with, and my answer makes sense because my answer makes sense. Okay? And why does my answer, you say, make sense? Well, first, because I multiplied after I did dividing, so I did the opposite operation. And when you do the opposite operation, that's a good way to check your work. Also, 13 pieces of paper. That makes sense because if I think about it, I need strips that are 1/6, and I need how many pieces? And it's a whole number. If I got an answer that was in a fraction, then that wouldn't make sense because I wouldn't want a fraction of a piece of paper. I mean, this piece of paper right here is one piece of paper. If I cut it in half, I still have piece of paper. It's just a smaller piece of paper. So that doesn't help us if we have a fraction. So we want to make sure that our answer does indeed make sense. And in this case, we want a whole number, which we got 13. So my answer makes sense. Okay. Awesome. So what I'd like you to do is to try these 4-word problems on your own. It's going to take some time, but I want you to work through them and take your time on them and do your best. And remember the 5 steps to help you solve the problems. Good luck. Keep soaring. Have a great day, Falcons.